Hi students, today we are discussing the module central force motion which is in your syllabus. So, firstly we need to know what is central force. The central force means it is a force which is always directed towards a point or that is always directed away from a point, and we can study it with some examples. Electrostatic force, gravitational force and restoring force in a simple harmonic motion, they are examples of central force. So, in the case of gravitational force, you know that we all of us are attracted towards the center of earth, that means towards one point, and that fixed point is center of earth. Similarly, in the case of simple pendulum, we are discussing about the motion of the bob. So, here you know that the bob is starting from here, then it is going towards here, that means the velocity will increase up to this point. When we are passing this equilibrium point, the velocity will decrease, and at last at this point the bob will get rest, then it will come back to this point. So, here you know that when the bob is here, the velocity is increasing up to here, that means here the force is up to this point, the force is to this point. Similarly, here also the acceleration is towards this point. So, we can say that here the force is directed towards this point, which is the equilibrium point. Okay, next we can discuss about the magnitude of this central force. In the case of gravitational force, you know that magnitude is proportional to 1 by r square, where r is the distance from fixed point to that body. Similarly, in the case of simple harmonic motion, the force is directly proportional to r, where r is the distance from fixed point to the body. So, here we can see that in every case the magnitude will be a function of the distance from fixed point to the body. So, here we can say that F is equal to F of r cap, where that F is the force and F of r is the magnitude of that force and r cap is the direction of that force. So, okay, and you know that suppose we are discussing about the force between two bodies, that is one particle is of m1 mass and another is mass of particle of mass m2. So, when we are discussing about two bodies, you know that there are more equations. If we are studying it in 3-dimensional motion, for one particle we need 3 equations. One may be in x direction, another one will be in y direction and another one will be in z direction. Similarly, if we are discussing about this one, we know that there are 2 particles are there, one is m1, one is m2. One is one of mass m1 and one is of mass m2. So, there will be 3 independent equations will be there for particle of mass m1. Similarly, 3 independent equations will be there for particle of mass m2. So, that will be somewhat difficult. So, instead of that, if we are converting this into one body problem, we need only 3 equations. Otherwise, if the 2 body problem is converting into one body problem, we can reduce the number of equations into half. So, we can study that. There are 2 particles, one of mass m1 and another one of mass m2, and r1 is the position vector of the first particle and r2 is the position vector of second particle, and the distance between these 2 particles are taking us r2 minus r1. So, we know the equations of motion. In the case of equation of motion, you know what is the equation of force. Force is equal to mass into acceleration. So, in this case mass of the particle is m1 and r1 is the distance, or r1 is the distance. So, acceleration will be d square r1 divided by dt square. Then the force will be F of r cap. So, here you know that in this case to the body m2 the force is directed to this direction, then for the next particle the force will be directed to the opposite direction. So, we can say for the second particle the force will be minus F of r cap. So, here the mass of that particle is m2 and the acceleration of the particle is d square r2 by dt square. So, we can write m2 d square r2 by dt square is equal to minus F of r cap. So, the first equation I can rewrite as d square r1 by dt square is equal to F of r by m1 r cap. I just bring this m1 to here. Similarly, I am bringing m2 from left hand side to right hand side, then I can write d square r2 by dt square is equal to minus F of r by m2 r cap. So, first this is the equation 1 and this is equation 2. So, what I am going to do is I am going to subtract equation 2 from this equation 1. So, I can write that is equal to d square r1 by dt square minus d square r2 by dt square, that is equal to 1 by m1 minus of minus, that is plus 1 by m2 f of r cap. So, this one I can write, it is d square by dt square of r1 minus r2, that is equal to f of r cap. But you know that r1 minus r2 is the distance between these two particles. So, that is equal to r. So, d square r by dt square is equal to 1 by m1 plus 1 by m2 f of r cap. So, 1 by m1 plus 1 by m2, that is I am adding these two things, that means m1 m2 is the LCM here, then m1 plus m2. So, that is equal to d square r by dt square is equal to m1 plus m2 divided by m1 m2 f of r cap. Then I am bringing this term to the left hand side of the equation. So, I can write m1 m2 divided by m1 plus m2 d square r by dt square is equal to f of r cap. So, this m1 m2 divided by m1 plus m2, we can say that is the reduced mass, and I am using a letter mu for that one. So, I can rewrite this equation as mu d square r by dt square is equal to f of r cap. So, you can see this equation. It is simply an equation of force F equal to ma, where that m is mu, that is reduced mass here, and d square r by dt square, that is acceleration, and f of r cap, that is a force. Okay. So, as a special case, here it is the origin. Instead of that one, I am taking center of mass as origin. You know how to take center of mass. The center of mass r is equal to m1 r1 plus m2 r2 divided by m1 plus m2. So, in the previous case, it is the origin. Now, I am bringing the origin to this point, that is here. So, here I am taking this r as 0 here. So, I can write this equation as m1 r1 is equal to minus m2 r2. But we already know that r equal to r1 minus r2. Then r2 can be written as r1 minus r, and I am substituting this equation 5 on this equation 4. Then I will get m1 r1 is equal to minus m2 r1 minus r. Then from there one, I can get m1 plus m2 r1 equal to m2 r, or r1 is equal to m2 r divided by m1 plus m2. Similarly, I can prove an equation for r2, that is equal to minus m1 r divided by m1 plus m2. So, I am taking a special case. In that special case, I am taking m2 is very much greater than that of m1. So, if I am going to this equation, m2 is very much greater than that of m1 plus. So, m1 plus m2 is almost equal to m2. So, this m2 and m2 will cancel each other, then I will get r1 is equal to r. Similarly, I will get r2 is approximately equal to 0. This thing is happening in the case of planet and sun. So, here sun is very massive and planet is not so massive. So, we are taking the mass of sun as very much greater than that of the mass of planet. So, here we can say that r1 is equal to r and r2 is almost equal to 0. That is why we are taking as sun is fixed at a point and planets are revolving around it. In the case of satellite and planet, also this is happening there. So, here in the case of Earth and Moon, Moon has the mass only of 1% of that of Earth. So, here also we are taking that Earth is fixed, then Moon is revolving around Earth. But in the case of Pluto, that was a Pluto and Charon. Charon is the satellite of Pluto. But Charon has the mass 15% of that of Pluto. So, there we are not taking Pluto is fixed and Charon is revolving around it. Charon and Pluto, they are revolving around each other on a common fixed point. Next is about the properties of center force. So, the center force we know that is always directed towards a point or that is directed away from a fixed point, and the force between them that will act in a line joining between the particle and that the fixed point. And another property is that one, center force is a conservative force. In the case of conservative force means conservative force have so many properties that del cross F equal to 0, curl of that force equal to 0, and the force can be expressed as gradient of potential. So, all these properties are applied for center force also. And another property is that angular momentum and energy of particle undergoing central force are constant, and the motion in central force that is confined in a plane, and radius vector sweeps out equal area in equal interval of time. So, we can study about that. So, central force is confined in a plane. You know what is force? In the case of central force, the force is equal to F of r cap, and you know what is torque? Torque is the rotational analog of force, which is the moment of force, that is equal to r cross F. So, we can find what is torque. Torque is equal to r cross, instead of S I am using the equation of central force, that is F of r cap. This r can be written as magnitude r and the direction r cap. Similarly, the force F can be written as magnitude Fr and direction r cap. So, we can write that torque equal to r F of r cross r. You know that if we are taking the cross product of a vector with that vector itself, we will get 0. That means this r cross r will be 0. That means torque will be 0. So, here we can write that torque can be written as the rate of change of angular momentum, where this angular momentum is the rotational analog of linear momentum. So, we can write torque equal to dl by dt. Since this tau equal to 0, we can write dl by dt is equal to 0. So, if dl by dt equal to 0 means the L or the angular momentum will be a constant of motion. Then I am going to take the scalar triple product. That means I am going to take the scalar product of the radius vector r with that of this angular momentum. So, that is equal to r dot r cross p. So, it is a scalar triple product. You know the properties of scalar triple product. That means if we are going to take the scalar triple product of 3 vectors, we can interchange this dot and cross product. So, this r dot r cross p can be written as r cross r dot p. Here also we are taking the cross product of a vector with that vector itself, that is r cross r, that will be 0. So, we can say that this r dot L equal to 0. So, what do you mean by this r dot L equal to 0? This r dot L equal to 0 means either r equal to 0 or L equal to 0, otherwise r and L must be perpendicular to each other. Here we know that r is not equal to 0 and L is not equal to 0. That means this r, that is the position vector, is always perpendicular to the angular momentum. So, here angular momentum is a constant of motion and position vector is always perpendicular to angular momentum. That means the central force motion is confined in a plane. Okay. Next, about this angular momentum. You know what is angular momentum? L is equal to mass into radius vector into velocity, that is the magnitude of that angular momentum mu r v, where this v is the linear velocity. That linear velocity we can represent that is as r omega, where omega is the angular velocity. So, the angular velocity we can write that is equal to rate of change of angular displacement. So, that is equal to d theta by dt. So, I am applying this equation 3 on this equation 1. So, I will get L equal to mu r square d theta by dt. This d theta by dt I am writing as that theta dot. So, we can write that this angular momentum is equal to mu r square theta dot. So, here the angular momentum is a constant. So, we can write that dl by dt equal to 0. So, that means d by dt of mu r square theta dot equal to 0. That means I am differentiating this one. Since mu is a constant, I am taking it outside and I am going to differentiate this r square theta dot. So, this r square, firstly I am going to take it as constant, then I am differentiating theta dot. So, theta dot means d theta by dt, once more differentiating means d square theta by dt square. So, I am writing it as theta double dot. Next, I am taking this theta dot as a constant and r square I am differentiating. R square differentiating means 2r into r dot. So, I can write that mu into r square theta double dot plus 2r r dot theta dot is equal to 0. So, in this case radius r is there in both the time. So, I am taking that r outside. So, here the remaining will be r here and r will not be here. So, I can write that mu r into r theta double dot plus 2r dot theta dot equal to 0. So, from there I can write this equation mu r theta double dot plus 2r theta dot equal to 0. So, next is about the energy. The total energy of a particle, you know, that will be sum of kinetic energy and potential energy. So, here the potential energy, that is u r, and here kinetic energy can be written as half mu v square. But here you know the motion is consisting of rotational motion and linear motion. So, the total velocity v can be expressed as r dot square plus r square theta dot square, where this r dot square is the linear velocity and r square theta dot square is the component of angular velocity. So, by applying this equation on equation 6, I can write the total energy E equal to half mu r dot square plus r square theta dot square plus u of r. So, from there you already know that this angular momentum is equal to mu r square theta dot. So, I am finding what is theta dot from this equation, that is equal to L by mu r square, and I am substituting this theta dot here. So, I can write this equation E as E is equal to half mu r dot square plus r square instead of theta dot square L by mu r square plus u of r. This can be written as half mu r dot square plus half L square by mu r square plus u of r. So, I am combining this half L square by mu r square plus u r as effective potential. You know it is the potential due to central force and it is the centrifugal potential, and I am adding these two potential and I am writing that as the effective potential. So, what here means this equation then I can rewrite as half mu r dot square plus u effective r, but here we can see that this equation is depending on only r, or the dependence of theta is not here, which is included in this centrifugal potential. So, I am writing the equation again, that energy E is equal to half mu r dot square plus r square theta dot square plus u of r. You know this energy is a constant of motion, so I can write that dE by dt equal to 0. So, which will be half mu, I am differentiating this r dot square, since mu is a constant I am not differentiating this one, it is a constant, and r dot square I am going to differentiate, then that will be 2 r dot and differential of r dot, that is equal to r double dot. Then I am differentiating this time, that is r square theta dot square. So, firstly I am taking this theta dot square as constant and I am differentiating r square, then I will get 2 r dot theta dot square. Similarly, next I am taking this r square as a constant, then I am differentiating theta dot square, then that will be equal to 2 theta dot theta double dot plus du by dt is equal to 0. So, I am expanding this, I am breaking this bracket. So, we can write that this half mu into 2, that 2 will cancel, here also this 2 will cancel, here also this 2 will cancel. So, the equation can be written as mu r dot r double dot plus mu r dot theta dot square plus mu r square theta dot theta double dot plus du by dr d by dt of r equal to 0. So, we already have an equation, which we discussed in the previous slide, that mu r theta double dot plus q r dot theta dot equal to 0, which gives that theta double dot equal to minus 2 r dot theta dot by r. Similarly, the central force can be expressed as f of r equal to minus du by dr. So, I am substituting this equation 14 and 15 on this equation 13. So, I can write that mu r dot r double dot plus mu r dot square theta dot square mu r square theta dot, instead of theta double dot I am writing minus 2 r dot theta dot by r, instead of du by dr we are writing minus f of r r dot equal to 0. So, here it is equal to mu r dot double dot plus mu r dot theta dot square minus this r square, this r that will cancel and this 2 will come here, and theta dot into theta dot, that will be theta dot square. So, I can write it is equal to mu r double dot plus mu r dot theta dot square minus 2 mu r dot theta dot minus f of r dot equal to 0. So, I can add this time and this time. So, I will get minus mu r dot theta dot square. So, the total equation I can write mu r dot r double dot minus mu r dot theta dot square minus f of r dot equal to 0. And all of this term contain r dot, I am taking it outside. Similarly, all of these terms contains r dot. So, I am taking this r dot outside and this r dot will not be 0. So, we can write mu r double dot minus mu r theta dot square minus f of r will be 0. So, I can write that like this, mu r double dot minus r theta dot square is equal to f of r. So, we are discussing about the equation of motion. The equation of motion means here the motion is a two-dimensional motion. So, there will be a radial motion and also a motion on theta. So, we are finding what is the radial velocity, and similarly what we are going to find what is d theta by dt. So, here the energy you know that is equal to half mu r dot square plus u effective r. So, from there you can find what is r dot square, that is equal to 2 by mu E minus u effective. So, from there you can find what is r dot, that will be the square root of that. So, this r dot you know that is equal to dr by dt. So, we are finding what is dr by dt, that is equal to root of 2 by mu E minus u effective. So, we found what is radial velocity. So, next we are going to find what is d theta by dt. You know what is angular momentum, that is equal to mu r square theta dot. From there we can find what is theta dot, that is equal to L by mu r square. This theta dot is equal to d theta by dt. So, we can find d theta by dt is equal to L by mu r square. So, we need to know what is the trajectory of that motion. So, here it is a two dimensional motion, that means that motion has dependence on theta and r. So, we need an equation which is connecting theta and r. So, we are going to find what is d theta by dr. This d theta by dr we can write, that is equal to d theta by dt divided by dr by dt, and we know what is d theta by dt, that is there L by mu r square, and we know what is dr by dt, that is root of 2 by mu E minus u effective, and we are substituting those values there, then we will get d theta by dr is equal to L by mu r square root of 2 by mu E minus u effective. So, just by integrating it you will get what is the dependence of r and theta, that means you will get the trajectory of the motion. The trajectory means what is the path followed by that object. Yes.